Have you ever booked an Uber ride, wait several minutes, and then had it cancel? In dense urban environments, ride hailing reliability depends on timing, demand, and operational decisions. Hi everyone, we're Team 230 Ashley, Thea, Thalia, and Kayla. Our project Urban Ride Insights use visual analytics to examine Uber trip data in India and uncover patterns in wait times, cancellations, pricing, and ride failures. Here's how we will walk you through our analysis today. Ride-hailing demand fluctuate across time, locations, and vehicle types. Understanding these patterns is critical for improving operational efficiency and rider experience. We built an interactive Tableau dashboard to support data-driven insight into urban mobility. Our analysis is guided by four questions. The first question is, how does wait time influence ride failure rates, including cancellations and incomplete rides? And how does this relationship vary by time of the day, vehicle type? These questions help us understand whether longer waits actually translate into higher failure rates. Our second question is, what are the primary driver of ride cancellations and how do cancellations reasons differ between drivers and customer across peak and off-peak hours? Here, we separate who cancel from why cancellations happen and which is crucial for targeted interventions. Our third question is, how do different vehicle types such as Go Mini and Uber XL compare in demand, wait time, ratings, and failure rates? And importantly, which vehicle types represent the greatest opportunity to reduce failed rides? And the last question is, to what extent do pricing levels and route characteristic, including distance, zone, and peak pricing, impact customer ride failure rates, particular in high volume zones like Delhi? This allows us to connect pricing strategy with customer behavior and outcomes. Our datasets come from the Uber Ride Analytic dashboard available on Kaggle. It includes Uber ride booking across India, with each row representing an individual ride booking, which is our unit of analysis. The datasets contain about over 140,000 ride records with attributes covering booking details, ride characteristic, service outcomes such as completions, cancellations, and failure. These datasets support both time-based analysis like hourly and weekly patterns, and categorical analysis such as vehicle types and cancellations reason. It enables us to explore demand trends, ride activity, service reliability, and operational performance. With our data objective and research questions established, we can now move into how we prepared the data and structure our analysis to uncover meaningful insight.
Overall, for data preparation, the dataset was fairly clean. We spent very little time handling missing or inconsistent values, though we did check for extreme or unrealistic entries. Most of the time was actually spent creating calculated fields, parameters, and other such features to better exploit the Uber data. One of the biggest tasks we handled was generating geocoordinates. We went through the data, we only had the location names, and so we went to Google Maps and matched the location names given in the data set to those in India's national capital region through whatever looked like it was the best fit. One of the other major ways we prepared the data was through aggregating. For example, we compiled different categories of ride statuses from 5 into 2 statuses: completed rides or failures, where the failures encompassed canceled rides, incomplete rides, and other such categories. Doing these activities helped better summarize ride activity and made it more pleasing for visualizations. To create our storyboard, we used descriptive and exploratory data analytics with a main focus on the impact of failed rides as well as Uber vehicle type. On the right, the map shows the 177 locations we were originally provided that were unique locations within the Uber data. We then took them and, using a calculated field, aggregated them into 6 different location zones, such as airport or Delhi, seen in the chart above the map, to create something that's more interactive, more easily able to be interacted with. We also created interactive filtering for dynamic exploration, such as date ranges that you could scroll through, um, and use things like clickable charts or even hovering over different vehicle types to filter down on your data as you scroll through the dashboard. We ended up going through 10 different versions of storyboards before we were satisfied that we had successfully balanced making an easily digestible storyboard that was also able to derive in depth analysis. As a result, we were able to turn a basic map into a route study where you can filter locations by picking a location and then comparing it with a location level pattern to discover where demand is most concentrated. We highlighted key details like the impact time of day would have on ridership, seen in the chart on the bottom left. And we even tried to point out when things were unexpectedly not significant, such as when, in the chart on the bottom right, higher number of rides in a month did not correlate with a higher price per kilometer per ride. We also manipulated data to showcase simple views of how different groups, such as, or once different groups were compared against each other, how those would be impacted by various things, such as wait times impacting the cancellation rates between drivers being different than between wait times with customers. The dataset gave many opportunities for data exploration, but there were also some limitations. The dataset didn't include anything that would actually impact some of the reasons why people would use Uber or the cost of Uber rides, such as real-time traffic or weather information. The geo coordinates that we created as they were generated might not have been accurate. We thought they were accurate. They did match names on Google Maps, but there's always a chance that because they were just location labels, the precise coordinates were off. Additionally, the data set was missing some key variables that prevented it from going from analysis that was more descriptive in nature, like what you did, to something that was more meaningfully predictive in nature. Some examples are below, where Uber riders in this data set were 99% of the time people who only used Uber once in the entire year, with only 1% of riders using it 2 times. Additionally, despite one of our main areas being the airport, wait time ranges were between 2 minutes and 20 minutes. I've definitely waited for an Uber longer than 20 minutes before. So there's just some things that were unrealistic. And other things were just weird. It could be accurate, but it was just unexpected. So they weren't included, such as the driver cancellation reasons were evenly split between 4 different categories. And even categories like sick customers happened as often as customer related issues for reasons that drivers would cancel. Overall, the data was great. And Thea will go into how we used this data, despite some of these limitations, to drive a meaningful analysis.
Now to discuss our actual dashboards and their breakdown. So we have two major components in every dashboard, which is the navigation component and the data results and analysis component. So the navigation component is used to navigate through the different dashboards and specify certain features. Oh my God, that's awful. Again. Now to discuss our actual dashboard breakdown, we have two different components that are very important. We have the navigation component and the data results and analysis component. The navigation component can be used to go through the different dashboards, go back and forth, and so on. And then the data results and analysis is obviously to analyze the specific data we chose to visualize and then see their analysis and the results. So first of all, we have the navigation one, which shows where you can press different buttons. For example, if I want to go to the vehicle type dashboard, I click the vehicle type button and it takes me to that dashboard. I can also go to the home page and the recommendations page. And then at the bottom, we have certain buttons that help us also navigate smoothly. We have at the leftmost the profile button, which shows us the authors of this actual dashboard. We have the back and forward buttons, which are pretty self explanatory. So you go back and forth in the dashboards in their specific sequence. And then we have in the middle the broom icon, which shows something that clears all active filters in the dashboard. So because all the dashboards have filters, sometimes we want to remove those and clear them. So we use that button. And then in the right most corner, we have the icon button, which if you hover over will give you a tooltip which clarifies what this specific dashboard is for and what certain features it has and filters that you can use to filter the information. So first of all, we have our homepage dashboard, which shows just general information about our data set. So first, we have all the locations that the drivers go to. We have the status of the bookings, so whether they're completed, canceled, or canceled by the driver or customer, no driver found or incomplete. And in the bottom, we have a line chart that just shows us the total booking by date to see when bookings were high and when bookings were low, so we can see the max and min highlighted. Then we have the total booking number. And then at the bottom right, we have this filter where you can specify the date period to see how the date changes and how the different behavior changes. And everything in this dashboard could be used as a filter to filter out other features within other charts. So if I click a place on the map, for example, it filters out all the other charts. And similarly for everything else, if I pick only completed, it will show the completed rides, etc., etc. Then we have the vehicle type dashboard, which just shows us the patterns for different vehicle types. So, for example, in the Uber India dataset, the most common vehicle used is the rickshaw, which is a three-wheel vehicle only available in India. And so, with that, we can use the vehicle filters to hover over the vehicle type, and that will filter out all the other data. So, with that, we can see, for example, how what's the average wait time for the vehicle type, what's the percentage of rides that are actually from that vehicle, the different ratings of drivers based on the vehicle type, and then the average price for these vehicles. So, how much price per kilometer, so how much they travel, and how much that would cost. And then we have the failed rides dashboard, which shows us the failed rides because we realized that out of 150,000 rides, only 93,000 were completed. So we wanted to explore the patterns in that and why rides were being canceled or incomplete. So this displays first the top is that canceled or incomplete rides based on the hour of day and month to see if there's some pattern there. And then we also wanted to see the routes which have the most cancellation or completion rates. And then we could use that to further analyze by using the cancellation dashboard, which shows us specifically for canceled rides why they were happening, who was canceling. So we have either the customer canceling or the driver, and those are for different reasons. And then we also wanted to see what peak hours these cancellations were happening. And we could see that it was peak hours, for example, from 5 to 8 and 9 to 11 in the morning, where we could see that the cancellation was highest, and so were the ride bookings, which is to be expected. And then we can use, for example, the customer reasons and click specifically to see the numbers change. So we could use that as a filter to see how or the values change and to see how, for example, the max and min and the canceled rides per the week are changing. And then we also wanted to see why rides were not being completed, which is a very important factor because the ride would start but not be completed. We also explored similarly what's the peak time and then what's the during the week. And there was also different reasons why the customer was not completing the ride. And we also wanted to explore the where the routes are with the most incomplete rides. And so, for example, I could specify the top routes with those most incomplete rides using this slider filter where I can put 4, 7, whatever number I prefer to see those routes. Then we have the ratings dashboard, which shows us driver ratings and what factors are impacting them. So, for example, how long the ride is in terms of distance and how long the time is taking for the driver to drop the people off. And then we have, as per the total number, how many driver ratings often range between 4.2 and 4.3, which is relatively high. And then we wanted to see just different days and how those affected. Then we have the wait time dashboard, which shows us how much people were waiting, obviously. And so we wanted to see, for example, by different vehicle types, how much were people waiting. So, for example, a rickshaw, which is a three-wheel vehicle, is expected to wait longer than a normal car, which goes much faster. And then we wanted to see the different range. So using the box plot, we used that. And then we also wanted to see if the wait time increased, if whether the customer or driver would cancel, and that was often the case. And usually, if customers were waiting for more than 12 minutes, they would cancel the ride. And then we have the hour of day and the average wait time. So we want to see throughout the day when was the wait time the most. And so that you could see that and their average. And then we have the routes dashboard, which shows us the different routes the drivers would take. So we split it into six zones, which are the airport, Delhi, Garzazad, Gargaon, Naiba, and Outer NCR. And from those, we can pick one of those as the pickup, one of those as a drop off zone, and see the patterns there. And we could see the most popular routes are, for example, from Delhi to Delhi. And with that, I can specify also, once again, the same filter, the top routes for this case. And then with those routes, we wanted to see most customers traveling around 20 to 24 kilometers, which around 1 kilometer per minute. So we put the arrival time and the ride distance to see those. Then we have the pricing dashboard, which shows us the payment methods, how much customers were paying, and different factors. So we can see that the most common payment method is the UPI, which is similar to Zelle in India. And we could also see which customers spent the most money. So we could use the filter here at the top to specify how many top customers I'd like to see. And then we have the more common routes and then what different factors affecting them. So the top routes would be how much pricing or like how much the booking value was. And so we wanted to see the pattern there. And then we have our recommendations dashboard, which leads us back to this video so the person or the user could watch the video and learn how to navigate the whole learn dashboards and then learn everything about it and take our key insights, which is our next section. So that will be all for our dashboard.
Now I'll walk through the key insights from our analysis. First, we find that wait time plays a critical role in ride success. While most rides have moderate wait times, cancellation risk increases sharply once waits become longer and more unpredictable, especially during nighttime. This highlights wait time as a major driver of ride failures. Second, cancellations are driven primarily by drivers rather than customers. This pattern becomes more pronounced during afternoon and evening demand surges, suggesting that supply ride constraints rather than customer dissatisfaction are the main issue. Third, vehicle type shows very different performance outcomes. Rickshaws stand out as the most reliable options with shorter wait times, while Uber XL experiences longer and more volatile wait times, leading to higher cancellation risk. This indicates that availability matters more than service quality. Finally, pricing alone does not explain ride failures. Cancellations tend to increase on high-demand routes where long waits and higher prices overlap. This suggests that customers are more sensitive to uncertainty and delays than to the price itself. To summarize our findings, we highlight four key conclusions. First, wait time is the most influential factor affecting ride success. Long and unpredictable waits significantly increase the likelihood of cancellations. Second, most ride failures are driven by driver-side behavior. This points to supply limitations rather than issues with customer experience. Third, differences in ride outcomes are driven more by vehicle availability and wait times than by service quality or ratings. Lastly, high-demand locations amplify operational inefficiencies, leading to higher ride failure rates. There are several opportunities to extend this analysis in future work. First, predictive analytics could be integrated to forecast ride-hailing demand. This would help anticipate high-demand locations and periods, enabling more proactive driver allocation and also operational planning. Second, incorporating external data such as weather, public events, and traffic conditions would provide additional context. This would improve both the accuracy and depth of analytical insights. Our analysis is based on a publicly available Uber Ride analytics dataset from Kaggle. We built the dashboard using Tableau, referenced publicly available information from Uber, and followed course materials and guidance provided by Professor Yazdi at Johns Hopkins University. Thank you for watching our presentation. We appreciate your time and attention.